Hello and welcome to this GCSE Science additional physics revision video on work, energy and momentum. In this video we'll cover work, gravitational potential energy, kinetic energy and momentum. Work is done whenever a force moves something. Everyday examples of work include walking upstairs, lifting heavy objects, pulling a sledge or pushing a shopping trolley. Whenever work is done, energy is transferred from one place to another. The equation to work out work done is force times distance. Work done has the same unit as energy, which is joules. This is because energy is the ability to do work. So you must have energy in order to do work. You do not have to work if you do not have energy though. For instance, potential energy does not do work. Specifically, a person could not push a box and so do work in the example that we've just talked about without any energy. On Earth, we always have a force of gravity acting on us. When we are above the Earth's surface, we have potential or stored energy. This is called gravitational potential energy. The amount of gravitational potential energy an object has depends on its mass and the height above the ground. The diagram above shows that all books on the shelf have gravitational potential energy. Book A has more than book C because it's higher. Book B has more than book A because it has a greater mass. The equation to work out gravitational potential energy is mass times gravity. On Earth, the gravitational field strength is always 10 times by height. Kinetic energy is the amount of movement energy that an object has. Many theme park rides use the transfer of gravitational potential energy to kinetic energy. In this example, as the pirate ship falls, gravitational potential energy is transferred into kinetic energy. At the bottom of the swing, travelling at its highest speed, it swings back up to the other side. The kinetic energy is transferred back into gravitational potential energy. A roller coaster car gains gravitational potential energy as it travels to the top. Once over the top, the car gains speed as gravitational potential energy is transferred to kinetic energy. As it travels to the top of another loop, the kinetic energy is transferred back into gravitational potential energy. Note that not all of the energy is transferred from gravitational potential energy to kinetic energy, as some is lost as sound and heat. All moving objects have kinetic energy, and it depends on the mass of an object and the speed of it. The equation to work out kinetic energy is 1/2 times mass times velocity squared. Remember, when working this out in your exam, work it out by velocity times velocity, then press equals, then times it by the mass, then press equals, then times it by 0.5. A moving object has momentum. This is the tendency of an object to keep moving in the same direction. It is difficult to change the direction of movement of an object with a lot of momentum. The equation to work out momentum is mass times velocity. Momentum is often represented by the letter P. The unit of momentum is kilogram per meter per second. Mass is given in kilograms and velocity is given in meters per second. When we talk about direction, we need to notice that momentum does not just depend on an object's mass and speed. Velocity is a speed in a particular direction, so the momentum of an object also depends on the direction of travel. This means that the momentum of an object can change if the object speeds up or slows down, or the object changes direction. When conservation of momentum needs to be considered, we need to think that as long as there is no external forces acting on the object involved, the total momentum stays the same. So the momentum before has to equal the momentum after. So if two railway carriages collide and move off together, carriage A has a mass of 12,000 kilograms and moves at 5 meters per second before the collision. Carriage B has a mass of 8,000 kilograms and is stationary before the collision. What is the velocity of the two carriages after the collision? After the collision, in any of these type of questions, we can consider that the two carriages have stuck together. So in this case, the mass after the collision would be 20,000 kilograms. So the first stage in working it out is to work out the total momentum before the event, which is going to be the momentum of carriage A before the event, which is 12,000 times 5, which is 60,000. The momentum of carriage B before the event, which is 8,000 times by 0, because it's not moving, which will give that total momentum of 0. So the total momentum of the two before the collision is 60,000 kilograms per meters per second. Step 2, we need to work out the total momentum after the event. Because the momentum is conserved, the total momentum after is the same as the total momentum before. We then need to work out the total mass after the event, which is carriage A plus carriage B to give us a total mass of 20,000 kilograms. We then simply rearrange the equation for V, which is velocity, is equal to momentum divided by mass. So we know that the momentum after is 60,000 meters per second, kilogram per meter per second, divided by a mass of 20,000 kilograms. So the velocity after must be 3 meters per second. When considering car safety features, we need to think about momentum. When there is a car crash, the car, its contents and the passengers decelerate rapidly. They experience great forces because of the change in momentum, which can cause injuries. Modern cars have safety features which absorb kinetic energy in these collisions, such as seatbelts, airbags and crumple zones. These features reduce injuries to people in the car by absorbing the energy of the impact. They increase the time taken for the change in momentum on the occupant's body and so reduce the forces involved in any subsequent injuries. These features absorb the energy when they change shape. This reduces injuries to the people inside the car. They increase the time taken for a change in momentum on the occupant's body, so they reduce any potential injury. Seatbelts stop you tumbling around inside of a car if there is a collision. However, they are designed to stretch a bit. This increases the time it takes for the body's momentum to reach 0 and so reduces the force on it. Airbags increase the time taken for the head's momentum to reach 0 and so reduce the forces on it when it hits the dashboard. Crumple zones are areas of a vehicle which are designed to crush in a controlled way during a collision. They increase the time taken to change the momentum of the driver and the passengers in the crash. This reduces the force. So remember, when revising, take your time, start earlier on in the day, keep asking yourself questions, and quality revision is better than quantity. Good luck with your physics exams.